Hello again, year 9, and in today's lesson we are going to be looking at a new sort of equation. They are going to be equations with unknowns on both sides, and what that means is the algebra will appear in more than one place. Fortunately, we can use the method that we've been developing over the last couple of lessons to solve these equations, whereas the method of flow diagrams does not work for these type of equations. But before we get started, let's begin with a little puzzle. You can see on the screen there is a star shape with lots of different little triangles making it up. And the question is, how many triangles make this shape? However, you do need to be careful because there are triangles of different sizes. So how many triangles can you see? I would pause the video here, perhaps draw it in the back of your book, and carefully count how many triangles you can see. Give yourself a couple of minutes to see if you can get an answer. So if we look at the solution to this problem, the first thing that I'm going to do is I'm going to count up the little triangles. Okay, and we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those. Okay, however, you will have probably noticed there's some triangles that are a little bit bigger. I could describe those that I've counted as a one side triangle, as in it's got one edge around its three sides. But there are some triangles that are this kind of size. So how many of those are there? Okay, well, there's one of those for each point of the star. So one there, 2, 3, 4, 5, and 6. Like I said, one for each point of the star. Finally, there are 2 very large triangles. One there and one there. So all together, there are 20 triangles in that puzzle. So I hope you've managed to print out a copy of the sheet. If you've not managed to do so, there are a few equation diagrams to draw today. We are going to introduce this concept with equation diagrams, but after a couple of examples, I'm hoping we can move away from needing a diagram. So our title is Equations 8. Our objective is be able to solve an equation with unknowns on both sides. I've then gone on to say, to solve an equation with unknowns on both sides, the first step is to eliminate the variable from one side. So this is what an equation looks like with unknowns on both sides. It means we've got some x's on this left-hand side, and I've got some x's on the right-hand side of my equation. Now, as an equation diagram, it would look like this. 3x's add 12 is the same as x plus 22. Now, the reason why we're using an equation diagram is because I want you to see visually what is the first step to solving this equation. I've said I want to get rid of the unknown on one side. Well, if I get rid of an x on this part of my equation, if I want to keep it equal, I need to get rid of one of the x's on the other side. And then these two things are equivalent. So what have I done there? Well, I have subtracted an x from both sides of my equation. So the first step is always going to be to subtract a number of x's today. or whatever letter you may be using. And what am I left with? Well, I'm left with 2x's and 12. So I've got rid of one of those x's, and I've got 2x add 12. What do I have on the other side of my equation? Well, I just have the 22, because I have got rid of that x there by subtracting x. So we've now reduced this to an equation that says 2x plus 12 equals 22. And these are the sorts of equations we've now been solving for several lessons. So what is my next step? Well, I'm going to use an inverse, and I'm going to get rid of add 12 by subtracting 12. What do I get if I subtract 12 from both sides of the equation? I get 2x's equals, subtract 12 from 22 is 10. So 2x's is 10. And to finish this off, I need to divide by 2. So in this equation, x equals 5. Now, just like a lot of equations, there is a way we can check our answer using substitution. Can have a look at this in the diagram as well. If we know that each x is worth 5, then this would be 5, this would be 5, this would be 5, and if I added 12, I would have 15 add 12 is 27. So that bar altogether would represent 27. If I put x is 5 here, I have 5 plus 22, and that equals 27. So both of my bars are the same value. If they hadn't come out as the same value, my answer to my equation would be wrong. Let's look at a second example with an equation diagram. But this time, I haven't said what the equation is. Can you work it out? Well, let's have a look. I have 5y's and 14. And I am saying that is the same as 2y's and 23. So my equation is 5y plus 14 equals 2y plus 23. Now, knocking a y off each equation this time doesn't really help me. I actually need to chop 2 of them off to get rid of the y's on this side. So this time I am subtracting 2 y's from each side of the equation. So if you're wondering how many y's will I need to subtract each time, look at your 2 expressions, look for the bigger number, subtract the smaller one. So if I subtract 2 y's, I'm going to have 3 y's left and the 14 still. If I subtract the 2 y's is going to be gone, and I'm going to be left with the 23. And again, this is an equation we've been practicing. So I need to use the inverse of add 14, which is take away 14. When I subtract 14, I am left with 3y. And when I subtract 14 from 23, I have 9. So 3y equals 9. I need to divide by 3 to work out what each y is worth. And 9 divided by 3 is 3. So y equals 3. However, I am hoping today that we'll be able to do some questions where we don't need to draw an equation diagram. So let's look at 2 further examples. So what is the first step? Well, I have an x and I have a 4x. So this is the side with the less x's on. So I'm going to subtract 1x from both sides. If I subtract an x from 4x, I have 3 x's left and still the takeaway 5. If I subtract an x from this side, well, that x is going to go and I'm just going to be left with 16. So our equation is now 3x take away 5 equals 16. So now using my inverses, I'm going to do the inverse of take away 5, which is add 5. When I add 5 to both sides, it is 3x equals 21. To work out x, well, I've got 3 of them, so I need to divide by 3. Dividing by 3 gives x equals 7. And again, if you want to check this, you can. If I go back to the start, if x is 7, 4 sevens is 28, and 28 take away 5 is 23. If I look at this side of the equation, if x is 7, 7 plus 16 is also 23. So these two sides of my equation are equal. Let's look at this final example. I have 9x plus 6 equals 31 plus 4x. Don't be put off by the fact that I've written this the other way round. On this side, I have 4x's, and on this side, I have 9x's. This is the side with more x's, so I'm going to subtract 4x's from both sides. If I subtract 4x's from 9x's, I will have 5x's left and the plus 6. If I subtract those 4x's, on this side, all I have left is the 31. So we have 5x plus 6 equals 31. So my inverse this time is to subtract 6. And as a result, 5x must equal 25. Finally, the inverse of times by 5 is divide by 5. So I get my final answer as x equals 5. So if you go back to my instructions, there are some questions for you to try. You can see that these must be a little bit harder because these come from the 4 to 5 textbook today. Do not be put off by the questions starting at question 7. Questions 1 to 6 looked a little bit different and I did not want to put you off. Now, if at any point when you're doing these questions you're not quite sure of that first step, then you can always ask in the Ask the Teacher channel and I will get you started. There is more than enough questions for today. I am not expecting anyone to finish all of these. As always, check your answers in the last 5 minutes and make any corrections. Remember, you can also check your answers by substituting your final value back in. As always, if you have any problems today, you can contact me in the Ask the Teacher channel.